Welcome to Who Wants to Be a Millionaire? I am your host, Pauline Ami, and today we have an eager contestant ready to take on a challenge for a lifetime. Please give a warm welcome to Mr. Raynor Caban. Raynor, are you ready to play for a chance to win 1 million pesos?
Absolutely, Queen. Let's do this.
Here's how the game works. You will face 8 questions, 2 easy, 2 moderate, and 4 difficult. The money prize increases with each correct answer, starting at 10,000 and reaching a whopping 1 million pesos. For your first 2 questions, for 10,000 pesos, what does the derivative of a function help find in calculus optimization? A. Maximum or minimum points. B. Inflection points. C. Critical points. And letter D. Points of discontinuity.
C. Critical points.
Correct.
The derivative of a function has to find critical points where the function rate of change is 0 or undefined. By analyzing this point, we can determine whether they correspond to maximum or minimum values, enabling us to optimize the function for either the highest or lowest point.
Let's move on to question number 2 for 20,000 pesos. Which of the following represents the derivative of the natural logarithmic function f of x is equals to ln x? A. 1 over x. B. 1 over ln of x. C. 1 over x squared. And D. ln x.
It's A, 1 over x.
Correct again. You're on fire. You just won 20,000 pesos. Moving on to the moderate question.
Answer A. 1 over x. The derivative of natural logarithmic function f of x is equal to ln x is equal to 1 over x. This result is obtained through the differentiation of rules for logarithmic function. The derivatives of ln x is 1 over x, reflecting the rate of change of natural logarithmic with respect to its variable x.
Are you ready?
Absolutely.
Question number 3. Solve lim of x approaching to 2, x cubed minus 7x squared plus 10x over x squared plus x minus 6. A. 56 over 0. B. 1. C. Negative 6 over 5. And letter D. 0.1.
It's letter C. Negative 6 over 5.
Correct. You've just won 15,000 pesos. Let's tackle question number 4.
First, derive the equation x cubed minus 7x squared plus 10 over x squared plus x minus 6 to 3x squared minus 14x plus 10 over 2x plus 1. Then distribute the x is equals to 2 to all the variables in the equation. After you distribute, all you need to do is to calculate the problem, and the answer is negative 6 over 5.
Let's tackle question number 4. Perform the indicated function evaluation for f of x is equals to 3 minus 5x minus 2x squared f of x plus h. A. 3 minus 5x minus 5h minus 2x squared minus 2h squared minus 4xh. B. 3 minus 2x squared minus 5h squared minus 5h squared minus 2x minus 2h. C. Both A and B. And letter D. None of the above.
For me, it's letter A.
Are you sure about that?
Yes, of course.
Correct again. You've won 100,000.
To evaluate f open parenthesis x plus h close parenthesis for the function of f of x is equals to 3 minus 5x minus 2 squared, substitute x plus h for x in the original function. Now you can simplify the equation, and now you can start using the FOIL method in x plus h squared. Now you can start multiplying 5 and 2 to the x plus h.
Rainer, you're doing fantastic. Now, get ready for the difficult question. Remember, you have 2 lifelines, 50-50 and phone a friend. Question number 5. A farmer wants to build a rectangular enclosure along a riverbank. The farmer has 500 meters of fencing material and wants to maximize the area of the enclosure. What should be the dimensions of the enclosure to achieve this? Letter A, length is equals to 125 meters, width is equals to 125 meters. Letter B, length is equals to 250 meters, width is equals to 125 meters. Letter C, length is equals to 125 meters, width is equals to 250 meters, and letter D, length is equals to 250 meters, width is equals to 250 meters.
I'm going to use my 50-50 lifeline.
Are you sure?
Yes.
So, the remaining choices are letter C and letter D.
I'll go with letter C.
Correct. You've won 250,000 pesos.
The correct answer C. Length is equal to 125 meters, width is equal to 50 meters. To explain why this is the correct answer, let's use the concept of optimization in calculus. First, let's define the variables. Let L be the length of enclosure, let W be the width of enclosure. The perimeter of the enclosure is given by the equation 2L plus W is equal to 500. We need to maximize the area of the enclosure, which is given by the equation A is equal to L times W. To solve this optimization problem, we can use the perimeter equation to express one variable in terms of other. From the perimeter equation, we can arrange it to solve for W. W is equal to 500 minus 2L. Substituting this value of W into the area equation, we get A is equal to L times 500 minus 2L is equal to A is equal to 500L minus 2L squared. To find the maximum area, we take the derivatives of A with respect to L and set is equal to 0. dA over dL is equal to 500 minus 4L equal to 0. Solving this equation, we will find L is equal to 125. Substituting this value back into the perimeter equation, we find W is equal to 250. Therefore, the dimension that maximizes the area of the enclosure well using 500 meters of fencing material and length is equal to 125 meters and width is equal to 250 meters, which correspond to option C.
You're halfway there. Let's tackle question number 6. A conical cup is being filled with water at a rate of 3 cubic centimeters per second. The height of the water in the cup is increasing at the rate of 2 centimeters per second. What is the rate of change of the radius of the cup when the height of the water is 5 centimeters? A. 0.5 centimeter per second, B. 1 centimeter per second, C. 1.5 centimeter per second, and letter D. 2 centimeters per second.
Let's go with letter B.
Correct. 1,500,000 pesos.
The rate of a change of a height of the water is the conical cup is given as 2 cm per second and the rate of the filling is given as 3 cube centimeter per second, we need to find the rate of change of the radius when the height of the water is 5 cm. The volume of cone is given by the formula B is equal to 1 over 3 pi r squared h, where B is the volume, r is the radius, and h is the height. Differentiating both sides of the equation with respect to time, we get dv over dt is equal to 1/3 pi times 2rh dr over dt plus r squared times dh over dt. Given that dv over dt is equal to 3 cube centimeters per second and dh over dt is equal to 2 centimeters per second, we can substitute this value into the equation. 3 is equal to 1 over 3 pi times 2rh dr over dt plus r squared times 2. We need to find the value of dr over dt when h is equal to 5 centimeters. Substituting h is equal to 5 into the equation, we get 3 is equal to 1 over 3 pi times 2r times 5 dr over dt plus r squared times 2 is equal to 3 is equal to 10 over 3 pi r dr over dt plus 2 over 3 pi r squared. Simplifying the equation, we find 3 minus 2 over r pi r squared is equal to 10 over 3 pi r dr over dt. Now we can solve for dr over dt. dr over dt is equal to 3 minus 2 over 3 pi r squared divided by 10 over 3 pi r. Substituting r is equal to h, we get dr over dt is equal to 3 minus 2 over 3 pi h squared divided by 10 over 3 rh pi h. Plugging in h is equal to 5 centimeters, we find dr over dt is equal to 3 minus 2 over 3 pi times 5 squared over or divide by 10 over 3 pi times 5 is equal to dr over dt is equal to 3 minus 2 over 3 pi times 25 divided by 10 over 3 pi times 5. dr over dt is equal to 1 centimeter per second. Therefore, the rate of the change of the radius of the cup when the height of the water is 5 centimeter is approximately 1 centimeter per second. So the correct answer is B, 1 centimeter per second.
You've made it to the final round with a chance to win 1 million pesos. Are you ready for the last two difficult questions?
Let's do it.
A farmer has 200 meters of fencing and wants to enclose a rectangular area along the side of the river. He does not need to fence the side along the river. What dimensions should he use to maximize the area of the enclosed region? A. 50 meters by 100 meters. B. 40 meters by 120 meters. C. 60 meters by 80 meters. And letter D. 30 meters by 140 meters.
I'm going to use my phone a friend on this one.
Are you sure of using it instead of using it for the final question?
Yes, I'm sure.
Here's the phone. So, who are you going to call?
I'm going to call my classmate from my school in University of Science and Technology in Southern Philippines, Joey Molina.
Okay.
So, Joey, here's the question. A farmer has 200 meters of fencing and wants to enclose a rectangular area along the side of a river. He does not need to fence the side along the river. What dimension should I use to maximize the area of the enclosed region?
Mhm. The answer would be A. 50 meters by 100 meters.
I'm going to trust my friend on this. It's letter A.
Are you sure about that?
Yes, I'm very sure.
Correct. You've just won 750,000 pesos. You're only one question away from 1 million pesos. Let's go for it. Question number 8. A balloon is being inflated at a constant rate of 2 cubic centimeters per second. The volume of the balloon is increasing at a rate of 8 cubic centimeters per second. What is the rate of change of the radius of the balloon when the volume is 100 cubic centimeters? A. 0.6 centimeter per second. B. 1 centimeter per second. C. 2 centimeter per second. And letter D. 4 centimeter per second.
I'm going with the letter A.
Are you sure?
Yes,
Is that your final answer?
yes it is.
Rainer, you've just won 1 million pesos. Congratulations. Thank you for joining with us on Who Wants to Be a Millionaire. Join us next time for more thrilling moments and big wins. Good night.